Okay everyone, welcome back. In this video I'm going to talk a little bit about the general guidelines that you should try to follow for any formal lab write-up, and then we'll talk in specific for those of you in Chem-Phys on the format for the Zircon Zinger Lab. So you always want to have a title, and you want to follow that with a statement of the purpose or the problem. What is it that you're trying to investigate, or what question are you trying to answer? Then we have a hypothesis, and remember the hypothesis is just an educated guess, and it's sometimes mathematical. So it could be stating what you think the equation could be. Procedure and materials. For this, you need to be very careful that your procedure is detailed enough that you could give it to another physics student and they could repeat the lab and get similar results. So it's not meant to be the longest novel you've ever written, but it needs to be detailed enough to be repeatable. The data usually goes in the form of a nice data table, and you need to have everything labeled. So units and variables, everything needs to be nice and neat. In a follow-up video, I'm going to say a little bit about how to make a data table in Excel, but for the most part, if you draw it on graph paper or in your lab book, you should be doing so with a ruler. The same goes for the graphs, and you should consult previous videos for more information about those. Now for this Zircon Zinger's lab, the first one, hand-drawn, is okay. But for most labs, your teacher will probably want you to print out your graph, and I'll say a little bit more about how to do that in a later video. The next major component are your results and analysis. So this varies depending on the lab, but this is where you state what the data is doing as seen by the graphs. Usually there are questions to answer, and again, this varies from lab to lab. And finally, you will have some sort of conclusion, and the idea behind the conclusion is that you take your data and you go back to the hypothesis. Was it confirmed? And then this is also a place to talk about sources of error. So this is the basic structure for most lab write-ups. And depending on what lab you do, this will vary a lot. You might have a lab where you don't have to do a hypothesis. It might be an investigation. You just want to see what happens. It might be very specific where the purpose and problem is given to you. It's all going to vary. Okay, so let's talk for a moment about what you need to do for the Zircon Zinger's lab, which is the first lab for my Chem-Phys classes. So that's going to be the title of this one, and everything except for the graphs needs to be typed. Everything needs to be typed except for the graphs. Okay? The purpose and problem I'm not going to restate because you should be able to find that in your notes or on your lab handouts. The hypothesis should be written neatly. It should be typed. Okay? And remember, we want to make sure that it has something to do with how distance and time are related. What do you think is going to happen? Procedure and materials. The procedure has to be step by step. You have to talk about the specifics of your setup. What else did you have to measure? How did you measure things? Where did you measure things from? Did you start at the top of the switch and go to the bottom of the next switch? What exactly did you do? Okay, so you can do this as sort of a step-by-step 1, 2, 3. You can also do this as a narrative, write it in a couple of paragraphs, but when you're done, give it to someone else to read and see if they can tell what you did in the lab. Okay, For data, we are going to type this, and we'll be talking in class about how to do this using Excel or other programs. So the other important thing is just make sure that you have a table with the units. Okay, so the graphs you've already done, so I'm not going to make you redo them. Hand-drawn is okay. Okay? However, they have to be neat. Alright? And as a reminder, you are going to have two graphs. Okay? The first graph is just distance versus average time. And remember that for this, we are going to have the uncertainties on that graph, but we are not writing any equations for that first graph. Then the second graph is distance versus t average squared. And this switches. We are not going to worry about uncertainties for that graph, but yes, we are going to write an equation, and this was your homework for Thursday or Friday of the week of September 10th. And we need to make sure to put that in the proper form. Okay, so instead of y equals mx plus b, remember that we're going to write something like d equals something times t squared plus something. And this is the slope, and this is the intercept. And make sure you go back and look at how to analyze a graph video if you have questions about those parts. Okay, now in the results for this lab, I'm going to ask you to answer two things. Number one, I want you to use your equation to find the time if the distance was equal to 200 centimeters. You can pretend like that has 3 sig figs because I said so. Okay, so use your equation that you came up with. Plug in 200 centimeters for distance and see if you can calculate the time that it should take. So this is known as extrapolating. We can't actually test 200 based on what we have in the lab. And secondly, talk a little bit about, so discuss the meaning of the slope on the second graph. So this is again the graph of distance versus time average squared, and what I want you to do is say a little bit about what's going on with this slope. Think about the units, okay, and go from there. Now in the conclusion, there's going to be three things that you're going to do. Number one, you're going to say, was your hypothesis correct? And you're going to support this using data. So for example, if you said that your hypothesis was distance is linearly related to time, that's how we would write that. So this means it's linearly proportional. You might not have written it like this. You might have said as the distance goes up, so does the time at a linear rate. If you said it like that, you have to support it using your data, using your equation. That's the first thing. The second thing is you need to describe 4 different sources of error. And this falls into 2 categories. Okay? The first category is what we call systematic. So these are things that you control. For example, if you came in one day and you didn't check the angle of your ramp, that's something that you messed up on. So try to write at least 2 of those systematic errors. And then think about what we would call random errors. These are things you can't control. Okay? For example, one thing that you can't control is getting a different marble each day. So think of a few of those. Okay, so all of this needs to be typed. Make sure you proofread it. Okay, no typos. Even though it's physics class, make sure your grammar is good. Okay, and that's pretty much it. If you have questions, we'll talk about it a little bit more in class, but we'll go from here.